Hello, my name is Ignacio Lacalle. I work in the coordination team of the project Assist IoT. This is a project under the code ICT46, targeting and developing the next generation of IoT architectures. What we are doing in this project, that has been, by the way, running since November 2020, we are trying to deliver an architecture which is composed of horizontal and vertical layers, trying to cover the different aspects that the next generation of IoT deployments require. Basically, we have departed from the assumption of microservices containerized applications that are decomposed in different horizontal and vertical places, targeting different functionalities, either devices, network, applications, or other vertical features like security, scalability, manageability. We have coined a term called enabler, in which we basically have designed a way of encapsulating these microservices so that they can be smartly orchestrated with some of the technology that we propose. We have and we evaluated technology that is now at the level of maturity reasonable, and we have developed it in 4 different boxes. It's 3 boxes, but we have split this one into 2. The first use case is about port automation. There we count with the Port of Malta, the terminal of the Port of Malta, and we are using our technology to allow better tracking assets in the yard and allowing with a partner called Cranes that has cranes that operate the cargo to do remote management with augmented reality tools that are empowered by our solution. Then, in a very interesting case, we have tested our technology in harsh environments in construction sites where workers enter and exit areas of the construction site that might entail some dangers. We made that monitoring with ultra-wideband connections, with anchors, tags, we interact and interface this with the BEIM models of the buildings, so that we kind of interoperate the different tools for providing a better monitoring of the health risks of the workers. Finally, in regards with the automotive, which is the third sector we tackle, we have split it into 2. First, we count with a car by Ford, Germany, with an open ECU, which is the device that gathers the information of the calibration of the engine of a car in real time. And based on that, we are able, together with high fidelity sensors, gather information and understand which is the level of pollution and emissions in real time of the car, and also thanks to our technology of edge computing together with cloud, we can scale it to a whole fleet of vehicles for better monitoring and acting upon these emissions. And secondly, we have a use case in which we use cameras for AI analysis of images that have defects in the surface of vehicles, and thanks to our technology and specifically federated learning framework that we have designed, we are able to make these scanners that make the images collaborate together for improving the performance of the code.
Our Assist IoT reference architecture is based around the structure where we identify planes and verticals that provide capabilities. Planes are device at edge, smart networking, data plane application and services plane, whereas verticals are vulnerability, scalability, security, privacy and trust, interoperability and self-start. Now, the development and technical part is focused around providing enablers. Enabler is a very important term in the reference architecture that we propose. An enabler can be understood as a collection of encapsulated components that to work together, provide some functionality, provide some interfaces. So looking at the landscape, at the possible deployment of Assist IoT, where we need to provide different features belonging to planes, belonging to verticals, we can select what type of enablers do we need, and we can point how they interact with each other, how the messages are exchanged in order to cover the landscape of the deployment that we are considering. Within the project we have proposed enablers for every plane that we have recognized. We have also proposed enablers belonging to different verticals, but sometimes verticals such as interoperability, scalability are also addressed simply by the design of how we approach what kind of reference architecture we propose. Some of interesting outputs of the project is one of them is Smart Orchestrator, and the idea of smart orchestration of enablers that allows to manage the deployment. It's underneath uses Kubernetes, Mano software. Another very interesting output is the customized IoT gateway, one that also has been developed. And here, to get some more technical details, I encourage you to check the project website and go to the deliverables where a lot more information is provided.